on digital electronics. Objective of this lesson is to discuss about serial adder function and its architecture and function, how the serial adder is constructed with the help of full adder and a delay element that we are going to study. Before that, let us once again see 2's complement adder subtractor with some more examples so that you will clearly understand the subject. Now, let us consider two numbers. A equals to 1011, B equals to 1010. Let us consider these two numbers. Addition of this, how much? And subtraction of this, how much? Let us see. So addition of these two numbers is 1 plus 0, 0, 1. 1 plus 0, 1. 1 plus 1, 1, 0. 1 plus 0 plus 0, 1. 1 plus 1, 1, 0. So this is the carry we got. So this is the addition result, total addition result. So in decimal, this is 11. This is 10. Now addition of this is 21. So we got the 21 here, addition. How? This is 16, 8, 4, 2, 1 weights. So 16 plus 8th place is 0, 4th place is 1, hence take 4 plus 4 and second place 2 place is 0, hence you should not take. Next plus 1. So how much it is? 21. That means 1011 plus 1010 is 10101. So this is the final result. You got the 21. Let us check by applying this to the circuit. Okay, when S equals to 0, it is possible to add S equals to 0. So here number A is 1, 0, 1, 1. So these are coming here 1, 1, 0, 1. So 1011 A number. B number is 1010. B number is 1, 0, 1, 0. Because S equals to 0, XOR gates acts as buffers only. Hence, they produce this bit output is B only. That means B, whatever the B value it has, it produce that only. So 0, 1, 0, 1. And this carry bit is here 0. Now the first full adder 0 1 0 inputs are there, hence the sum is 1. For the second adder, it is sum is 1, carry is 0. Hence for the second adder we have 1 1 0. That means 1 plus 1 plus 0. That means sum is 0, carry is 1. Next third adder 0 plus 0 plus 1. It is 1, carry 0. Next 1 plus 1 plus 0. It is 1 0. 1. You see, observe here. You got the result. It is 21. It is 21. We have verified already. So let us do the same for subtraction also. For the subtraction, what do we get? Number A is 1 0 1 1. Number B is 1 0 1 0. Let us subtract. Minus 1 minus 0 1, 1 minus 1 0, 0 minus 0 0, 1 minus 1 0. That means it is 11 minus 10 is 1 in decimal. So you got in binary the same result. Let us verify this by applying these inputs to the circuit. So A inputs are 1 0 1 1. B inputs are 1 B inputs are 1 0 1 0. These are the B inputs, and S equals to, because we want to do subtraction, S equals to 1. So that 1 is coming to the, it is coming to all the XOR gates, because it is a control signal. S equals to 1 is connected to all the XOR gates, and also it is connected to the first full adder. Hence that 1 comes to first full adder and all XOR gates. That is the important point you have to remember. So now hence when S equals to 1, control bit is 1, then the XOR gate will complement its input. That is, it is 0 complemented, 1 is complemented, it is 0, 0 is complemented, it is 1, 1 is complemented, it is 0, 0 is complemented, it is 1. So these are the inputs, and the first full adder is getting the carry bit also 1. So first full adder addition, 1 plus 1 plus 1, 1 plus 1 plus 1, it is 1 0. Carry is 1, sum is 1, 1 1, 1 plus 1 plus 1, it is 1 1. So carry is 1, sum is 1. Now second full adder, 0 plus 1 plus 1, it is 1 0. carry is 1, sum is 0. And third full adder, 1 plus 0 plus 1, it is also carry 1, sum 0. Next, fourth full adder, 0 plus 1 plus 1, it is 1, carry 1, sum 0. Neglect the carry, always neglect the carry. So what is the answer we got? 0, 0, 0, 1. That means we got the required answer. That means number A is 0, 1, 1. Number B minus B. Minus B equals to B bar plus 1. So that is, how do we get B bar? We got 0, 1, 0, 1. And this plus 1 is the first full adder plus 1. So that is the meaning. Minus B bar is B bar plus 1. This plus 1 is this. This B bar is this. This is the B bar. Now if we do the addition, 1 plus 1 plus 1, it is 1, 0. 1 plus 1, 1, 0. 1 plus 1, 1, 0. Here, this is 1. This is 1. 1 plus 1 plus 1. It is 1, 1. So carry 1, sum 0. 1 plus 1, carry 1, sum 0. 1 plus 1, carry 1, sum 0. Next, 1 plus 1, carry 1, sum 0. So this is the final carry which should be avoided. So you got the result. That means in the using the addition circuit, we are able to get the subtraction result. That means A plus B bar plus 1 is A minus B. This is the important thing we have seen in the previous class. Now let us see the serial adder construction and its working, and also comparison between serial adder and parallel adder. So we had discussed in the earlier classes of adder, full adder and parallel adders, and now let us see the serial adder architecture. Here if you observe here, full adder, one full adder is there. So A, B, C, N are its inputs and sum is its output. Carry C out, carry out is its output. Now and input A is receiving data from a serial in, serial out shift resistor. This is the serial in, serial out shift resistor. The initially the data is loaded into this resistor. Data A is loaded. That data A is loaded into this, and next so not serial in, parallel in, serial out, serial data. This is the parallel load, and here serial in parallel load, both are available, and it is a shift register. Now clock and load or shift, these are the control signals available to the shift registers. Now the data initially, data B is loaded parallelly into the register, data A is loaded into the register parallel load initially. So both the data items are available in the registers, two registers, and these registers outputs are connected to respective A and B inputs of full adder. And for each clock input, one bit is shifted to the right, and those bits are available for the full adder to add. So full adder, after addition, the sum is going back to here, that means shift register. That means after addition, the end result is stored in A register only. Once the result is stored, the previous data is erased. Now register serial in parallel load and serial out register B is also the same, but the result does not affect this data byte. So only two nibbles are taken, for example, in this case, and these are the two registers and one full adder, and this C out of full adder is connected to delay element, that is the D flip flop. So for each clock pulse, the output of the D flip flop is Q, and for each clock pulse, Q equals to D. For each clock pulse, Q equals to D. So this is the output equation of D flip flop. Hence, for each pulse, the input, that is C out from the full adder, carry out from the full adder, is produced as an input to full adder as seen like this. So operation of a serial adder. So we know that the serial adder having only one full adder, the numbers to be added are applied at the input bit by bit and added. First, the two LSBs are applied at the inputs of the adder. We get the sum S0 and carry C0. The carry is taken and fed back to the input in such a way that it adds onto the next bits A1 and B1 of the given number, giving the sum S1 and the carry C1. This process is repeated until all the bits of the numbers are added. So now let us see with one example. So observe here, the at time t0, initially at time t0, inputs are A0, B0, and carry in is 0. So that is the initial. The full adder adds these three bits A0 plus B0 plus carry 0 and produces S0. and this S0, this S0 is coming to uh, accumulator A like this, it is shifted like this and occupies the MSB, and MSB bit shifted to right side, that is into the next lower position, and like that each bit is shifted right side. And you observe here register B is feedback into itself, that's all, it is feedback into itself. That means LSB comes to MSB and MSB goes to next lower position and next lower position goes to next lower position, like that. Like this these bits are shifted, and so after first addition, that is the thing. Next the carry bit is produced here, it is produced here, and that is fed back to here also, it is fed back to here also. That means now A0 in this so now this is the case in the at time t1, what happens is A1 is available as an input to full adder, B1 is available as an input to full adder, and C1 is available as an input to full adder. So that is the status. So these three are added now and it produces S1 and C2. S1 and C2 is produced. And once it is there, once clock pulse comes here, what happens is this at time T3, at time T3, at time T3, what happens is T0, T1, this is the T0 time, this is the T1 time, this is T2 time, that means T2 pulse. Once that pulse comes here, what happens is this S1 is shifted into accumulator A, and the bits of B also shifted, rotated left, and the C2 is shifted to here. That means now to the full adder A2, B2 and C2, these are available to the full adder at time T2. At time T3, what happens is that means once again these bits are available. Now the full adder will add the bits, 3 bits, it produces S3, S2, not S3, it is S2. S2 is produced and C3 is produced here. Next, at time T3, what happens is because already S2, S3 are produced and available at the output of full adder, at time T3 the pulse comes. Once clock pulse comes, what happens is this sum bit is fed back to accumulator, and that B register is rotated left, it is rotated left. And once this rotation is done, what happens is at the input side C3 is available, C3 is available, A3, B3 is available. So these 3 bits are added by full adder and it produces S3, S3. and it produces C4. And in the next, the same thing happens, and here C4 is delayed and fed back to uh, full adder, and A4 is available now, A3 is available now, B3 is available. Now these bits are once are they are available, the full adder produces the output at a time T4. T4. So this is the operation of serial adder. Now let us see the operation of serial adder according to the pulses. Truth table. How does it work? Now let us consider two examples. X equals to 0 1 0 1, y equals to 1 0 1 1. So these are the bits. So it should add and give us the result like this: 1 plus 1 1 0, 1 plus 1 1 0. Okay, once again let us take x equals to 0 1 0 1, y equals to 0 1 1 1. So 1 plus 1 1 0, 1 plus 1 1 0, 1 plus 1 plus 1 1 1, 1 plus 0 plus 0 1. So this is the actual addition, and this addition we should get by the serial adder finally. So let us verify whether we get or not. At time t0, x value is this, y value is this. Okay, and the initial carry input is 0. This is the initial carry. So once 1 1 0 is available, that means first A0 bit, X0 bit, this is the Y0 bit, X0 bit, Y0 bit, both are available 1 1, and C input is 0. So 1 plus 1 plus 0 is 1 0. That means sum is 0, carry is 1. So this is the output of the full adder. So sum is 0, carry is 1. Now in the next pulse, the next clock pulse, what happens is, and after addition it will shift. That means this sum bit is shifted into x bit. That means this sum bit 0 comes to MSB like this, and this y number is rotated left. It is rotated left. That means this 1 is shifted to MSB bit, and all the bits respectively shift by one position. Hence we got this number. That means 1 1, that means 1 0 1 1 we will get like this. So this is after rotation, this is the bit. Okay, now in the t1 time t1, what happens is this, not only that, the carry bit also shifted, the carry bit also shifted after delay. That means d flip flop q equals to d. Once the clock pulse comes, what happens is, because its input is 1, that is shifted to output. That output is the ci, it is the ci. So in the previous diagram you can observe this. You see, so this is the one. That means once clock pulse comes here, this is the clock pulse. For every clock pulse, this is the new time instant. New time instant. That means shift operation and delay flip flop output q equals to d happens. Like this. That means whatever the output that is produced, it is shifted to here. Q equals to, this is the output, this is the output, this is the output, this is the input of the D flip flop. For every clock pulse, the bit is shifted, and when this is shifted, these sum is shifted to this resistor, and each bit also of this resistor will be shifted right. And not only that, this bit, another number b is rotated. In that case, in the table it is shown as y, this is shown as y, this is shown as x. So x bit is x resistor and y resistor bits. Now let us see how does once again. Okay, now at T1, the bits available to the full adder is 0, 1, 1, 0, 1, 1, and 0 plus 1 plus 1. It is 1, 0. That means 1 carry is 1, sum is 0. So this is the out. Once this is produced, new clock pulse comes. New clock pulse comes. Once new clock pulse comes here, T2. T2 is the new clock pulse. So once new clock pulse comes here, what happens is, so this is the new clock pulse. So the x, the sum bit here is shifted to here. Sum bit is shifted to here, and this carry bit is shifted to here. That means to the input of the full adder. Carry bit is shifted by the D flip flop, and some bit is shifted into the X resistor, and each bit of X resistor also shifted right simultaneously. So next, this Y bits are rotated left. The Y bits are rotated left by 1 bit. By 1 bit. That means like this. This is the rotation, left rotation. So that means 1, 1, 0, 1. So you see, I would like to tell rotation. I would like to tell the rotation here. One, 0, 1, 1. Rotated. Rotated means this one this one goes to here, that means 1. This 0 comes here, that is 0. This 1 comes here, that is 1. This 1 comes here, 1. So 1 1 0, that is the single bit rotation. So here we got like this, this is the one we got. So this is the thing. Next next pulse, in the next pulse what happens? So next pulse comes here. Okay, once this is available, x0 is 1, y0 is 1, c input is, carry input is 1. That means 1 plus 1 plus 1, that is 1 1, that is 1 1. This is sum is 1, carry is 1. This 1 1 is available at the output of the full adder. At the output of full adder, these 2 bits are available. Okay. Next what happens is, once they are available, next pulse comes here. Next pulse is the T3. Next pulse is T3. Once T3 comes, what happens is, each register bits are shifted. Each register means X register is shifted right by 1 position, and Y register bits are rotated left by 1 position, and D flip flop will shift the carry input to output, that like this. You see, D flip flop. That means at T3 pulse came here, hence each bit of X is shifted and some bit came here, the sum bit of previous stage. The sum bit of previous stage comes here. Some bit came, and y is rotated left by 1 position, hence it is now 1 1 1 0. Rotation, how does it do? I told you already. Now the carry bit here by the D flip flop, it is its input is 1. Now D flip flop input is 1, then the output is produced, that is q equals to ci, that means q is nothing but ci. So this one comes here as an output, this one comes as output here. Now what are the inputs to the full adder? Now 0, x0 is 0, y0 is 0, carry input is 1, that means 0 plus 0 plus 1. Sum is, then sum is 1, carry is 0. Sum is 1, carry is 0. Now what happens is, next pulse comes here. In the next pulse, what happens is, the sum bit is shifted into the MSB position of the X, and each other bits of X is shifted right. So that means this sum bit, came here as MSB, and each bit of other bits of X are shifted right. Hence we got 1 1 0 0. And Y bits are rotated left by 1 bit position. Hence we got this. And C, that means full adder output, carry output is this, that is shifted out, that is Q out is this, that means C input to the full adder. So this is the operation of serial adder. Similarly, you can take different examples and you can analyze the circuit, because for every clock pulse, this will happen. And you see, this is the important diagram you have to learn. So this is the important. You see, full adder output, some bit is shifted into MSB position of X input, and each bit of X other bits of X are shifted right by one position, and Y bits are rotated left like this. Y bits. Okay. Now let us take another example like this. 1001 X input, Y input is 0111. This is the Y input. Let us consider these two numbers, and this is the full adder, and it will produce sum and carry, and delay line is there. Okay, let us consider here, this is the D flip-flop, delay line flip-flop, it produce its output like this. That means 3 bits are given here. Now let us take, for example, the first initial carry is 0, hence first bits are available 1 1 0. Full adder output is 1 0. That means carry is 1, sum is 0. So the sum bit is coming and occupying the MSB position, and each other bits are shifted right. Hence, what is the new bit pattern? 0 1 0 0. These are the bits. So the previous this is over. So this is the new X, and okay, next this Y is rotated left. That means 1 0 1 1 1 0 1 1 rotated left. So hence let us erase this. This is rotated left, and next this bit is shifted to here. This is shifted to here. Let us erase previous. So now observe here, the new bit patterns 3 bits are available as input to full adder as 0 1 1. X is 0, Y is 1, carry is 1, 0 1 1. So it is output is 0 plus 1 plus 1 is 1 0. That means 1 0. So these sum bit comes to MSB position of X, and for the next pulse, I am telling, and this carry bit is comes here, and these bits are rotated. Once the pulse comes, this is the pulse, clock pulse. Once clock pulse comes, this bit is shifted like this. Okay, let us write for the new case. So because sum is 0, MSB position, and each other bits are shifted 0 0 1 0. And similarly here for the rotation of x number is 1101, and shifting of carry by the delay line is 1. Here 1 we got. Okay, let us erase. Now, what are the new bit patterns now? 0, 1, 1 as inputs. That means 0 plus 1 plus 1. The output is 1, 0. 1, 0. Hence, same thing now. Once another pulse comes here, what happens is this 0 is shifted to MSB position. That means 0, 0, 0, 1, 0, 0, 0, 1, and this Y number also rotated left. That means 1, 1, 1, 0, 1, 1, 1, 0, and this carry bit is shifted to its output like this. Okay, carry 1. Okay, this is okay. So these are the new bit patterns. So now let us erase the previous ones. Let me erase this. Okay, now the full adder will add, it will add 1 plus 0 plus 1. 1 plus 0 plus 1. That means 1, 0. 1, 0. So this is the way how it adds the bits of X and Y serially. Okay, with this let us compare serial and parallel binary adders. Parallel adder is faster, serial adder is slower one. All the bits, second point, all the bits can be added simultaneously in the parallel, but in the serial adder only bit by bit is possible. Number of full adders required is equal to number of bits, but only one full adder is enough irrespective of number of bits. So parallel adder is costly, this is economical, cheap. So these are the comparison. Next summary, we have discussed serial adder and compared serial adder and parallel adder. Which one is the true statement? The serial adder requires only one full adder. When speed of arithmetic addition is the main criteria, then the adder prepared is serial adder. Previous year examination questions comes like this. Serial adder is the comparison. These are the two assignment questions you have to learn. Thank you.